static, but we're also talking on an internet connection here.
Yeah.
I'm using Google Phone.
That's weird.
Yeah, I don't know what's wrong. You sure you don't have your microphone accidentally turned off?
Yeah, it's on.
Okay. Well, we won't worry about it. This works pretty good. You want to start with 1?
Yeah.
Well, I'm a little confused with 1.
Me too.
Aren't there supposed to be 8 rectangles?
Yeah.
Okay, good. Because I believe the picture you've drawn is correct. Except there would be 8 rectangles, not 4. So I don't know if they've made a typo here or what.
Yeah.
But I can't imagine how you would connect these 2 hexagons with 4 rectangles, to be honest. So I think it's a typo. We'll go with that. What's the name of that?
I have no idea.
Prism.
A prism.
Okay. A prism is a solid object that has 2 equal and opposite bases. In other words, the hexagon and that hexagon are opposite one another. They're equal. And if you were to slice this in between, your surface would be a hexagon also.
Yeah.
So that's what a prism is. Notice that what you've drawn here, what's that? Is that a triangular prism or is that a triangular pyramid?
Triangular prism.
Right, because once again, that base, that triangle, is the same as that triangle, and if you slice this perpendicularly anywhere, you get that same triangle.
Yeah.
Whenever you're looking for the volume of a prism, you take the area of the base times this length. And just remember that, and then that covers like hundreds of different kinds of figures. But that's why prisms are studied separately, is because it's real easy to find the volume. You just have to find the volume of one base and multiply it by its height or its length or whatever this dimension is. Okay. Number 3. I'm going to draw a picture of number 3.
Okay.
When they say there's a region with a 7-mile radius, that's what it means. It means everybody that lives in that region lives within a 7-mile radius of the center of that circle. So, if we know how many people live in the region, what we want is how many people live per square mile. How many square miles are there in that circle? It's not 7. In other words, you can't take 26,500 and divide it by 7. 7 is merely the radius of that circle. What's the formula for area of a circle?
Pi r squared.
So in this case, it's 49 pi square miles, or miles squared.
Yeah.
Okay, so that's the area. So if we take $26,500 people and divide it by 49 pi square miles, what units do we end up with? In other words, this is equal to some number, and our units are people per square mile. Still there, Julian? I feel like I lost you.
Yeah, absolutely.
Okay. So what's this number? 26,500 divided by 49 pi.
540 pi.
We want a number without the pi in it, in this case. First of all, pi is in the denominator, so you wouldn't get pi in your answer.
Okay.
So let me just make sure you know how to do this on your calculator.
Okay.
All right, we're taking 26,500 and dividing it by 49 pi. $26,500 divided, I need parentheses, 49, where's the pi key on this thing? Okay, I see it, pi. Now, you see how I've typed that in? You need that parentheses. Otherwise, if you don't have it, it's going to take 26,500, divide by 49, and multiply it by pi. So we need that parentheses. And that number is 172. They want you to round this round to the nearest whole number. So what is it? Your volume dropped way off. There you go. Yeah.
Alright, would it just be 172?
Yeah. So the answer is 172 people per square mile, and that's what they were asking, was find the population density in people per square mile. Okay? So the key is you got to determine the area, which means you got to determine the area of the circle. All right, let's go to number 4. Now these are a little tricky, I noticed, but you've actually done pretty good on most of them. By each rotation in three-dimensional space, so if you rotate an isosceles triangle about the triangle's line of symmetry,
okay,
you get a cone.
Yeah.
And just to be clear, is this all your work?
Yeah.
Okay. If you take that isosceles triangle and rotate it, when it says rotate it about its line of symmetry, that's its line of symmetry.
Okay.
Okay. Notice that why that's a line of symmetry. It's symmetric on both sides of that line, right? If I were to draw the line of symmetry this way, well, clearly that is not symmetrical on both sides of that line.
Yeah.
So there's a bunch of lines of symmetry on a triangle.
Okay.
One is the vertical one.
Yeah.
That's also another one.
Okay.
And that's a third one.
Alright.
So we just need one, because when you rotate this thing about it, about any of those three, you get the same cone. In other words, imagine that I spin that thing this way.
Yeah, our teacher did like a demonstration.
Yeah. And you end up with a cone, a perfect cone. rotate a square about a line that goes through the endpoints of the height. Well, the endpoints of the height are these 2 points here. And if you rotate that about those endpoints, you get, oddly enough, a cylinder.
Yeah.
I mean, it is a little odd that with you start with a square, you end up getting a cylinder. And if you start with a triangle, you end up getting a cone. You wouldn't expect that until you start thinking about how that thing would look. And believe it or not, when you get to calculus, this is critical, this kind of thinking. In fact, this is very much what calculus is all about, is rotating squares about the x-axis or about these 2 endpoints and then figuring out what the volume of the resultant figure is. That is calculus almost in a nutshell. Describe the 3 types of cross-sections formed by the intersection of a cube and a plane. Now, if there's anything that's more difficult to do online than solid geometry, I'm not sure what it is.
Okay.
Okay? And you understand why? Because unless I'm a great artist, and I am not, it's very difficult to describe what we're talking about.
Yeah.
Let me make an attempt. First of all, I'll draw a cube. Okay. Now, obviously, if I cut it with a line, let's say a knife, right there, straight down, I've got a square. I've got a surface area that's a square, right? In other words, if this is a square piece of cheese and I'm trying to slice it in half, I'm still looking at a square on that face. How do you get a triangle?
You cut the corner.
Yeah. You slice it at an angle like that in that direction. In other words, if you were to slice a corner off of the piece of cheese, you'd be looking at a triangle.
Yeah.
Well, what's the third? There's 3 of them.
Okay.
Besides a square and a triangle, what else could we get?
A rectangle.
Yeah. In other words, if we slice it, say, from this point here to a lower point in the back, you're going to get a rectangle.
Yeah.
Because of the angle. In other words, the angle is such that all 4 sides would not be equal. They wouldn't be able to. Because you're going at an angle, the hypotenuse has to be the biggest side. So the rectangle is the third there.
All right.
Okay, you want the largest possible water tank he can transport. And it's got to fit into this cube-shaped trailer.
This one kind of confused me.
Well, it's not that hard.
Okay.
I should have left my cube up there. There's the trailer.
Alright.
Okay. Cousin Henrietta builds tanks as cylinders or spheres. So we got 2 choices here.
Okay.
We can put a sphere inside of this 8-foot cube, 8 foot on each side. And I would draw it, but then it would be hard to erase. You can imagine, right? So what would the radius of the sphere be?
4 maybe?
what would the volume of the sphere be? What's the volume of a sphere? The general formula. 4/3 pi r cubed. Okay. So the volume of the sphere, and I'm going to put a little subnote S, meaning the volume of the sphere, is going to equal to 64 times 4/3 pi. So it's 4/3 pi times 64, which is what? 256 pi over 3. So that's the volume of the sphere that you could fit inside that cubic trailer. Now let's look at the volume of a cylinder. What is the volume of a cylinder? General formula. Remember, a cylinder is a prism. So you should remember this. All prisms, the volumes are the area of the base times its height. So let's write that. The area of the base for a cylinder is pi r squared times its height. Okay. Now, for a cylinder, what is r going to be? In other words, I'm going to put a cylindrical base. I can build the cylinder like that. So what is this distance from here to there? What's its height? I'm losing your sound again. Yep. It makes all the difference in the world, whatever it is you're doing there.
I would just like to
Okay. Probably getting away from the speaker makes the difference. Or the microphone, rather. So what is the height of this cylinder?
Is it square?
What's h? What's this dimension right here?
2.
That's 8.
Okay.
I couldn't hear what you were saying. So the volume of the cylinder is equal to pi times r squared, which is 16, times 8. Well, that is only 128 pi.
Alright.
So which is bigger? Get your calculator and tell me what 256 divided by 3 is.
That's 85.
Wow. And change, right?
Yeah, 0.333.
So you're telling me that the cylinder holds more volume than the sphere.
I guess.
I would have bet all the money in China that it was the other way around. Only because a sphere is the most efficient shape on the universe. There's nothing that packs more per punch than a sphere or a circle. That's why pi is such an important number in mathematics. So did I make a mistake here? Let's look at the volume of the cylinder. The sphere is definitely 4/3 pi r cubed, and r is clearly 4. 4 cubed is 64. 4/3 pi times 64, and this is pi times 4 squared times 8. Wow. It looks like the cylinder wins. You know, that's not that amazing when you think about it. I'm sure you've driven around town and you've seen things, and they're packed in cylinders.
Yeah.
In trucks. You know, some truck carrying a bunch of water or something.
Like cement.
Yeah, right. Those tend to be cylinders or cylindrical in shape. But you don't see a lot of spheres.
Yeah.
But still, this shocks me. Interesting. Well, there's a perfect example of mathematics at work, because I think if you ask most people, they would all say sphere would be the most volume that you could fit into that cube. Who knew that you could fit a higher volume cylinder? Unless I'm making a mistake. Sometimes I make mistakes. This could be one of them, but I don't think so, though. I mean, we checked our math pretty. Pi r squared times h is definitely the volume of a cylinder, and 4/3 pi r cubed is definitely the volume of a sphere. So, can't argue with the math.
Okay.
Next problem, 7.
Alright.
There's a kite.
Yeah.
This is D1. This is D2. Measurement from vertex to vertex. Both cases. What is the area of that kite?
10 units squared.
Well, let's just the general. I've become a real fan of starting out every problem with the general formula, because you need to memorize these general formulas.
Okay.
Okay? And that's why I want to start out every problem by stating what it is.
Okay.
You'll eventually memorize them all. What's the area of that kite, do you suppose? What would you guess? They've only given you 2 measurements, a D1 and a D2.
Maybe D1 plus D2.
It's D1 times D2, but is it this or is it this divided by 2?
It's divided by 2.
Yeah. Why? Because watch what happens if I draw a rectangle around this kite.
Yeah.
What's the base of that rectangle? D2 or D1? D1. This is D1. This is D2. The area of that rectangle would be D1 times D2.
Yeah.
And this clearly is not as big as that rectangle. And in fact, triangles are half rectangles. That's why the area of a triangle is 1/2 base times height, whereas the area of a rectangle is base times height. Okay? So, as long as you can remember that it's D1 times D2, you'll figure out that you have to divide it by 2. In other words, it wouldn't make sense for the area of this triangle or of this kite to be D1 times D2, because we can clearly draw a rectangle around it, and the area of the rectangle is D1 times D2.
Okay.
Okay, so that's the way you remember stuff like that. Okay, so they said rewrite the formula to solve for D2. So let's apply algebra 1 and solve that equation for D2
Okay.
before we substitute any numbers at all. So how do you solve that for D2? What's the first step?
Multiply by 2.
Okay, so now I got 2a equals D1 times D2.
Yeah.
Now what?
And then would you divide by D1?
Very good. So dividing both sides by D1 gets rid of it over here, and now we have solved it for D2.
Okay.
So D2 is equal to that. Now let's plug in. Find D2 if the area is 10 square units and the length of one diagonal is 4 units.
Okay.
So D2 equals what?
10 units squared.
It's 2 times A.
2 times A.
So it's 2 times 10
Alright.
divided by
D1, which is 4.
D2 is 5.
Yeah.
Okay?
Okay.
It's actually good. You probably can use some algebra practice. Area of a triangle is what?
Base times height, 1/2. 1/2 base times height.
That's the way I prefer to remember rather than base times height divided by 2. Those are the same things.
I don't know why.
Well, they're the same thing. There's nothing wrong with either one. It's just that, I don't know, for me, I like saying half of base times height rather than base times height divided by 2. I just am more comfortable with it. Conceptually, it seems like this clarifies it a little bit better.
Yeah.
So solve this for H.
Okay.
First step,
You have to find the base and height.
no. First step for solving for H. I've got to try to get H isolated.
Okay, so just algebra.
Uh-huh.
Alright, so,
Same thing we just did.
did you divide half?
Now, because I've written it this way, it's confused you.
Okay.
If I wrote it the way you wanted me to, now what's the first step?
You multiply by 2?
Yeah. Well, notice that's the same thing as this.
Yeah.
So don't be confused by the fact that the half is out there all by itself. I'm still going to multiply both sides by 2.
Yeah.
When I multiply the left side by 2, and I multiply the right side by 2, that 2 cancels with that, and I lose that number. So now I got BH equals 2A. What's H going to be?
36.
No. Let's solve for H before we substitute any numbers in. In other words, the first part is solve the equation for H.
Is it 2A over B equal this?
Uh-huh.
Alright.
Now start substituting numbers in. So the height is equal to what? The area is 36, so what should I write?
36 units squared.
What happened to the 2? Here's our equation.
Okay.
So H is equal to 2A divided by B.
Yeah.
Okay, well, if we're substituting, we can't ignore that 2.
Yeah.
The area is 36.
Yeah.
And what's B?
9.
Solve that equation and you get 8.
Okay.
So the height of a triangle is 8 if its area is 36 and its base is 9.
Okay.
Okay. Okay, all of these are kind of similar. this one, they give you the area of the trapezoid. So we'll start with that. You don't have to have that memorized. It's 1/2 the height times the small base plus the big base. Remember, a trapezoid looks like this.
Yeah.
Where this is one base and this is the second base.
Okay.
Okay? And the way I memorize the area of a trapezoid is it's the height times the average base. And this is the vertical height they're talking about, incidentally.
Okay.
Okay? And in other words, it differs from a rectangle only in the sense that a rectangle, B1 and B2 are the same. Right?
Yeah.
So a rectangle, you would say height times base. Well, I like to think of a trapezoid as the height times the average base. The average base would be about there. How do you get the average base? You add base 1 plus base 2 and divide by 2.
Okay.
So I prefer to write this formula as the height times the average base, which is this way, divided by 2. Now, it's kind of the opposite of the triangle. I prefer the half out in front with the triangle, but for a trapezoid, I prefer to write it like this, because the way I memorize the trapezoid is it's the average base. And you get the average by adding the 2 and dividing by 2. Okay? So I like to memorize it like this better. Okay, and they want to rewrite this and solve for h. First step. This is a 2, incidentally. First step. No. Their request is for you to rewrite the formula and solve for h. In other words, they want you to do some algebra before plugging in the number. Just like the previous 2 problems.
Would you multiply by 2?
Okay, that's first step. We're solving for h.
Okay, so we have to get rid of B1 and B2.
How do we do that?
You divide.
Because notice that B1 plus B2 is currently multiplying h. So if I divide by B1 plus B2, then I can cross that out and leaving h. Well, I got to divide this one by B1 plus B2 also.
Yeah.
So there's the formula for h.
Okay.
Okay? Now we can plug in everything that we see. So I'll write h on the left.
Okay.
Tell me what to write on the right.
Right, so... yeah, so how do you know which base is which?
Doesn't matter. I gotta need both of them. Because I need both of them. In other words, 14 plus 22 is going to be the same as 22 plus 14.
Yeah.
So it doesn't matter. But tell me what else I need to write here.
90.
Hold on. What happened to the 2? Well, we got to write it. In other words, if I'm solving for h, I can't write 90. That's a.
Okay.
I got to write 2 times 90.
Alright, so 180?
Well, let's write it like this first of all, because you keep wanting to forget that 2. So it's better if we write it like this.
Okay.
And then we'll simplify. And now I can write 14 plus 22, and notice that I don't care which base is which, because the other way to write it would be 22 plus 14. Okay, so this is 180 in the numerator, 36 in the denominator. That's equal to 5.
Okay.
So the height is 5.
Okay.
So all of these problems are, you're seeing the similarity, right?
Yeah.
In other words, we take what our normal formulas are, we algebraically manipulate them to solve for a different variable, and then we plug in the unknown numbers.
Okay.
Sketch a rectangular prism with dimensions L, W, and H with a cone of radius R and H height on top. Alright, I'm going to draw the rectangular brick. Now, it doesn't say that it's a cube.
Yeah,
But I'm going to make it a cube.
okay.
Why am I going to make it a cube? In other words, I can make it any rectangular brick. This is L. This is W.
Okay.
And that's H.
Alright.
Okay. And it says now put a cone with radius R and height H on top. Well, the reason I made this a cube was so this would be a square. So I could fit the base of the cone perfectly tangent to the sides of the square.
Okay.
And as far as putting the cone on top, there it is. Now, the radius of the cone is 1/2 of L.
Okay.
Now, when they said a height H on top, I'm not sure if they mean the same exact H as this H or not, but we'll assume they do.
Alright.
So that's H, the height of the cone. Now, write an equation that describes the volume of the shape drawn.
Alright.
What's the volume of the cube or the rectangular brick? I'm going to call it.
R squared.
No, that's for circles.
Base times height times width.
There you go. L, in this case, times W times height. The 3 dimensions of our rectangular brick. Whether it's a cube or not, that's the 3 dimensions multiplied together gives you the volume.
Okay.
Whether it's a brick or a cube. Now, what's the volume of the cone? Let's go over here on the left. The general formula for the volume of a cone is what?
Is it pi, wait, no, 4 over 3.
You're close in your thinking. It's 1/3.
1.
The volume of the equivalent cylinder. If I were to make that a cylinder instead of a cone,
Yeah.
well, the volume of the cylinder would be pi r squared times h, right?
Yeah.
Well, you lose 2/3 of it when you shave it to a point.
Okay.
So what's left is 1/3 of the volume of the cylinder that would have been there. So the volume of the cone is 1/3 pi r squared times h. Okay? Let me erase the cylinder. That's just kind of for an easy way to memorize it. And incidentally, that's true whether it's cylinders or triangular pyramids. If they go to a point, the difference between their volume and a rectangular solid is 1/3. You lose, if you take something to a point in the center, you lose 2/3 of what the volume would have been. And what I'm talking about when I say triangular pyramid, if I start with a square and make it go to a point like that, I can't draw worth here. That'll help. Okay. You see, that's a triangular pyramid. You had a question earlier in this paper, what's the difference between a triangular pyramid and a triangular prism? Well, a triangular pyramid is like a cone. And the volume is very similar. It's 1/3. And it doesn't matter whether the base is a square or a circle. If it goes to a point, it's 1/3. It can be a hexagon base. If it goes to a point, it's 1/3 of what the volume would have been had it been a prism. Okay? So, now they say, what is the volume of both? Describe the volume of the shape drawn. Well, that would be the volume of the cube plus the volume of the cone. So, if I add the volume of the cone, well, it's 1/3 pi r squared h, but some of these variables we know. What is r relative to L? Yeah, so the volume of the cone is actually 1/3 pi times half L squared times h. So the volume of both of them, if we add them together, is this becomes 1/4 L squared. In other words, when I square 1/2 L, I got to square the 1/2 and I got to square the L. So if I want to remove these parentheses, I got to replace it with 1/4 and leave the squared on the L. Okay. So there's the volume of the cone. There's the volume of the cube. Add those two together and you have the total volume. And there's not much way to add them together. The h's are the same. We're thinking they are, at least. So if I just put a plus sign in front of them, I've added them together. And I don't see a whole lot that we can do. I got LWH plus 1/3 pi times 1/4 L squared times h. I could factor out an h, but that's all I could do. Now I could factor out an h and an L. So let's just do it just for the heck of it. Let me show you what I'm talking about. Here's what we got. LWH plus 1/3 pi 1/4 times 1/3 is 1/12. We'll just make that 1/12. L squared h. Well, notice that I can factor out an L times h. What's left behind?
Factor out the h, would it just be width plus 1/12 pi? Is that length squared?
Right, but I'm dividing L into that, so I'm only going to be left with an L. Okay? And that was good. When you are done factoring, always multiply it back together to make sure you got what you started with. In other words, if I distribute this LH to this quantity, I end up with LHW plus 1/12 L squared pi h. And that's what I started with. So that tells me that I factored it perfectly. And doing that little test is very important. And I'm talking about for the next 3 years. You can't imagine how much factoring you're going to have to do over the next 2 years at least. So every time you factor something, multiply it back together again to make sure you got what you started with. And this would be an acceptable answer to their question. But so would this be. They didn't say factor anything out. So both of those are the same thing.
Okay.
How would your equation change if the cone was cut out of the rectangular prism?
I don't know.
I assume they mean just eliminate the cone, right?
I think so.
Because the volume of the cube with the cone on top is the same as the sum of the volume of each. There's nothing lost or added. In other words, I could take this cone and move it over here, this little Hershey Kisses, and move it over to the left so that it's not on top of the cube.
Yeah.
And so the volume of the cube would just be LWH.
Okay.
Okay, so that's the answer to C. It seems a little trivial. I can't believe they asked it. I assume that's what they mean. Maybe I'm not interpreting their question right, but all right.
Okay.
We got 10 minutes. All right, let's see if how many of these we can do. True or false? If you believe the conjecture is true, state that it is true and explain your reasoning. Use an example if it helps you. If you believe it's false, state that it's false, and rewrite the second part so that it makes it true. All right. Considering the following conjecture. If you double the length of a rectangular prism, you double its volume. Is that true or false?
That's true, right?
Yes, it is. Because notice that the volume, let's call this rectangular prism instead of cube.
Okay.
Because a rectangular prism would have 3 dimensions, L, W, and H. Okay? So if I make L 2L,
yeah,
well, it doubles the volume.
Yeah.
In other words, if I substitute 2L for L, that gives me 2V. So I double the volume. So that conjecture is true. And we explained our reasoning.
Okay.
So 12. If you double the base radius of a cone, you double its volume.
Okay.
Well, let's look at a cone. Now, if you don't know how to figure these out, the best way is to pick some numbers.
Okay.
What do you think is going to happen if I double the radius to the volume of the cone? Remember what the volume of the cone is. 1/3 pi r squared times h. So doubling the radius does what to the volume?
Would it quadruple it?
You got it. Very good. Very good. In other words, if I substitute 2r for r, I've got 1/3 pi times the quantity 2r squared times h. Well, that's 1/3 pi 4r squared h. Well,
Okay.
that is precisely 4 times that.
Yeah.
So, that's false. And how do we have to change it to make it true? If you double the base radius of a cone, then you do what to its volume?
I don't know.
Quadruple.
Quadruple?
That's what 4 times is.
Okay.
Okay? So you knew that it was 4 times, you just didn't know the word quadruple?
Yeah.
Okay. But when they say, take this premise and change it so that it's true, we just did. In other words,
Okay.
if you double the base radius of a cone, then you quadruple its volume. You don't double.
Okay. Okay.
And let's see, we got 5 minutes. Let's look at 13.
Alright.
When you put an object into a container of water, it raises the water level 3 centimeters. Container is a rectangular prism whose base measures 10 by 12. Without the object in the water, the water is 8 centimeters high. What is the volume of the container with just the water in it? What 3 numbers multiplied together are going to answer this?
8, 12, and 10?
Yeah. In other words, I'm having a little hard time interpreting their problem here. But because what's the volume of the container? Well, the volume of the container is the volume of the container. That's not really what they're asking with just the water in it. Having water in it or not doesn't change the volume of the container, right?
Yeah.
So they haven't given us the height of this container.
Okay.
So we really can't answer A
Okay.
the way they've stated it.
Okay.
Clearly, the container is tall enough to allow the water to rise 3 inches or 3 centimeters when you put this object in it, right?
Yeah.
So it must be higher than 8 centimeters, the container itself.
Okay.
And the little picture you've drawn over here makes it look like it's 11, which would be a reasonable guess, but it could be 15 inches high, right? It could be 25 inches high. Because all we know is that when there's 8 inches of water in it, and we put an object and it causes it to rise 3 centimeters, that's all we know. We don't know anything about the height of the container. So the volume of the container with just the water in it, answer that, impossible to tell.
Okay.
Okay, that's the correct answer. And I think they want your answer 96. That's 960, excuse me. That's what I think they want, but that's not really the correct answer.
Okay.
Because they've asked the question incorrectly. Unless I'm misinterpreting it, but I don't see how you know the height of the container. What is the volume of the container with the water and the object in it? Well, that's 11 times 12 times 10. You got that right. Okay.
Okay.
And when they say the volume of the container, they really mean the volume of the container up to the water level. That's really what they're asking. They're not asking for the volume of the empty container.
Yeah.
Even though that's what you would typically think they were asking.
Yeah.
What is the volume of the object? That's the tricky one. Yeah, actually you've got it just right. It's the one number minus the other number.
Yeah.
Which also happens to be that extra 3 inches that it moves up times 12 times 10.
Okay.
360. All right.
Okay.
Perfect timing.
Yeah.
That was a fairly tough one tonight.
Yeah.
Okay. Good job. I'll talk to you next week.
Okay.
Or
Thank you.
whenever, next time.
All right.
All right, Julian. Bye-bye.
Bye.